Alright, today we're going to go over a different kind of equation in the sense of the solution that comes out. So far we're used to equations always coming out to x equals like 7 or whatever, but we are going to be looking at a type of equation where there's not always a clear answer. Sometimes we will have no solution, and sometimes we will have many solutions. So this gives us three kinds of solutions. One solution, which is what we're used to, many solutions, and no solutions. So it's going to look like this. So we're going to go over that today. You will get a paper emailed to you, and we went through it in class today. I did a couple of the problems on the board for practice, and everybody else worked on the rest of it throughout class. So we're going to go over those ones that we practiced on today. Once I get done erasing all this. All right. So we're going to start with number 2 on the packet. So number 2 is 36 minus 7p is equal to negative 7p minus 5. Alright, so continuing on what we learned from the last chapter, we're going to start with the parentheses. So we're going to apply the right side in order to combine like terms. So negative 7 times p is going to be negative 7p, and negative 7 times negative 5 is going to be a positive 35 because of the negative on the outside and the negative on the inside. So we're going to drag down the left side now. So we've got 36 minus 7p. So next step is we're going to start combining our like terms. So we can move this 35 over here. That way we get a nice clean 1 minus 7p is equal to negative 7p. Now we need to get the variable by itself, and we're going to get plus 7p plus 7p, and we're going to get 1 is equal to 0. Because these variables canceled out right here, we have, technically, you could say 0p, or that just comes out to 0, because anything times p, or anything times 0 is 0. So this is a special kind of solution called the no solution. So when you come across a problem like this, you will work it down to this part where you'll get a constant is equal to the incorrect constant. 1 is never going to equal 0, just like 2 is never going to equal 3, and as you go. Like 1 will only ever equal 1. So this is a special kind of solution called no solution. We're gonna do alright, so now we're gonna try out problem number 7. Number 7 states negative 4 times v plus 3 is equal to negative 12 minus 4v. So like we learned last chapter in 2.3, we got to distribute first. So negative 4 distributed to v is going to give us negative 4v. And then negative 4 distributed to a positive 3, negative and a positive make a negative, is going to give us minus 12. I'm going to drag down the right side. We've got negative 12 minus 4v. And you might be looking at this and you're like, wait, how am I going to combine like terms? They're the same on both sides. Which we're going to go ahead and combine like terms to show what that's going to come out to be. So plus 12, they both cancel. We've got negative 4v is equal to negative 4v. Now we can go ahead and get rid of the negative 4 by doing the inverse operation, which is going to come out v is equal to v. And when you've got an equation like this, this is what we call many solutions, or all real numbers. So this means it doesn't matter what you plug into V, it's always going to be the same. You can set V equal to 6. When you plug in 6 to V, you're going to get 6 is equal to 6. That's true. If you want to plug in 10, 10 equal to 10, that's also true. So when you come across an equation like this, you're going to label it all real numbers, but make sure to get into its base form. There's another way to look at it. Sometimes your variable will cancel if you go about it a different way. That's going to look like this. So instead of taking care of the 12s right here, we are going to rewrite it right here. And we're just going to go ahead and write it in the same form on both sides with the commutative property of addition. When we do it, we're going to get rid of the variables first instead of the constants. So plus 4v plus 4v. When you do that, they cancel, and when you drag down, you've got negative 12 is equal to negative 12, and which is true. And you could use negative 12 to plug into v, like over here. But if you want to, we can simplify it further, technically, by combining like terms, because they're still like terms. We're going to add 12, add 12. They're going to cancel. We're going to get 0 equals 0. So your all real numbers form is always going to be in the form of your variable equal to your variable, or your constant equal to your constant. So you're either going to get, in the most simplified form, 0 equals 0, or honestly in the variable versus variable, if you simplify it further, and you will still get 0 equals 0. So all real numbers is always going to be in the form 0 equals 0. We're going to go through 2 more examples. Oh, there we go. All right, so let's look at number 10, okay? Number 10 says 4 distributed to k minus 8 is equal to negative 32 plus 4k. So we're going to go ahead and distribute on the left side so we can start combining like terms. And when we do that, we've got 4k minus 32 is equal to minus 32 plus 4k. This looks a lot like the last problem, right? It's because it technically is. Like, it doesn't matter what you plug into the variable. Like, you can use any solution for it. So when we're combining like terms, we can get rid of the constants. We're going to get 4k is equal to 4k. Get rid of the 4's using inverse operations. We've got k is equal to k. We can reduce it even further, like we said before. It's still technically reducible by dividing, or honestly, you don't have to divide. That's just a habit of mine. You can do subtraction. So minus k, it's going to give you 0 equals 0. You can use any inverse operation right there, technically, except multiplication and addition. And that's going to get you 0 equals 0. So this is another example of all real numbers. Or you might even see the term infinite solutions. But we want to stick with this term. This is what you'll probably use in high school. All right, we're going to look at one more example. We're going to look at number 12. 12. So number 12 says negative 1. So there's no 1 on the paper, but remember, if there's a negative outside the parentheses, you can just put a 1. Or if there's no, like, it doesn't matter if it's a negative or not. You can always just put a 1 there if it helps out. So negative 1, 3 minus 6b is equal to 6b plus 5. I don't like how the b and the 6's look the same, but we'll work with it. So we're going to combine like terms and distribute our negative to here. That's going to give us negative 3. And then we're going to distribute the negative 1 to the minus 6b, and the negative make a positive 6b is equal to 6b plus 5. And now when we go to combine like terms, we can get rid of this 3 first. Add that over here. That's going to give us 6b is equal to 6b plus 8. That is the worst b I've ever seen. Let's try that again. B. All right. We can simplify, but also we can just look at this equation up here, and we can tell that these are not equal. You can't have the same variable on the both sides set equal and also have constants being applied to them differently and they be equal. So when we simplify it to prove what we already can infer from here, we get 6b is equal to 6b plus 8, and then we can get rid of this 6b to get this constant by itself, minus 6b. We're going to get 0 is equal to 8. Now, I don't know about you, but 0 is never equal to 8. If somebody asks me, do I want lunch today, and I say no, and they bring me 8 sandwiches, that's not the same answer, is it? So we're going to put a little cross through here. That means not equal, but when you're working this out on your homework, you're going to label this as no solution. But make sure you get to this point right here, and that way you can justify how you got no solution. You could be like, no way 0 could ever equal 8. And you can always like check your work by plugging it in, which you can't plug anything on here because we never got a variable answer, so we can't plug a variable in. So that is the 4 examples I'm going to go over on the worksheet we did in class. If you could finish the rest of them on your own, there's 8 left. Also, you have workbook page 27, questions 1 through 7 as well to do to get more practice. It's pretty straightforward. I know you'll get the hang of it, and good luck.